Okay, so now I'm going to go over quiz 1 from Math 171. The first problem is just a converge problem mainly, but you have to, write some observations and stuff like that after you do the graphs and the tables and converge. So it says problem 1, use the 5-step process outlined in the supplement and include the following. So include a graph, so that's first. And here was the key, very close to the limit point. A lot of people who lost some credit for this, it's because they didn't draw the graph close enough to the limit point. Okay? So the function is 6 to the x minus 2 to the x over x, and you want this limit as x approaches 0. Alright, so I'll go to converge, and I'm going to do calculus, approach the limit graphically, and I'm going to type it in myself, and it's going to be, and a couple people made this mistake, you need parentheses around that whole numerator. So it's parentheses 6 to the x minus 2 to the x, excuse me, close parentheses, divided by x. And a lot of people did like a window of -2 to 2. To be able to get a great window, a great idea of what the limit is. So what I recommended people do is use, at minimum, like -0.5 to +0.5. Okay, because that's pretty close at least to 0, right? It would have been better really even to do like -0.2 to +0.2 or -0.1 to +0.1. Okay, and then if y went from 0 to 2, then we'll see what our picture looks like. So you see how detailed that is and how close you can get, right? Just from the graph, you can see that the limit there is right about 1.1, right? It looks like it's smack dab in the middle of 1 and 1.2, right? So just from the graph, I would say the limit is 1.1, right? So the idea of this is do a little sketch where you've got, whoa, that's terrible, sorry. You know what? Do that over. That's a little better. Right? So you went from -0.5 to +0.5, and I went from 0 to 2. So that was 1, that was 2. And then what did the graph look like? Just give a little sketch. Right? It's something, oh, let me see it again. It looks something like this. Oops. Right? And the limit, well, that's it. That should be an open circle, right? The limit there was right around 1.1. So the idea of this is the observation it appears that as x approaches 0, y approaches 1.1. So that's kind of the idea there, right? Obviously my graph isn't as good as that one because theirs is labeled by tenths, but I didn't make it big enough to do that. But you can see clearly from the converge graph that it's right around 1.1. So that was the idea. You want to be able to get a good idea of what the limit is just by looking at the graph. Okay, so that's doing it graphically. And then 2 tables. Now for the 2 tables, I would probably use the calculator. But I'll use converge because I don't want to have to open the calculator. So let me close this off. And now if I say approach a limit numerically, which means I'm doing a table, and I type it in as 6 to the x minus 2 to the x over x, same thing, it's already in there. And I want the limit as x approaches 0, let's say from the left. So what do I want to do? I want to put in like negative 0.1, negative 0.01. Oh, sorry. All right, I want to put in negative 0.1, negative 0.01, negative 0.001. Oops. What happened here? Right? So you can see there that if I just copy that table from negative 0.1 on down to the bottom there, that's a good table, right? Copy those rows. Of course. I don't want to have to write it. That's the problem. But you can see there that as x gets closer to 0 from the left, the limit is basically like 1.099, right? So you can get it a little bit more detailed if you use the table, because then I could even put in negative 0.00001 and see. So it's like it's 1.099 basically. All right. That's probably what it's going to be if you want it to round to 3 decimal places. It all depends on how many decimal places you're rounding to. Okay, so that would be a left-hand limit. So you would write a little observation there, and you would say, as x approaches 0 from the left, y approaches 1.099. All right, and then you would do the right-hand limit. Approach another limit with the same function? Sure. Now I just do 0 again, but I'm doing it from the right. And I'm going to do 0.1, 0.01, 0.001, 0.0001, 0.00001. And again, you can see there, now from the right, it looks like it's also 1.099. Right? I could go to more decimal places, but 3 decimal places is at least safe, right? So you would write that first observation under the one table, and then the other observation you get would be the same, except now it's as x approaches 0 from the right side, y is approaching 1.099. All right. So there's your observation for the other table, which you would have just copied down some of those rows. Okay. And then the final conclusion basically is just saying, all right, well, based on my graphical and numerical evidence, I would say the limit as x approaches 0 of this function, 6 to the x minus 2 to the x over x, is approximately 1.099. So that would be my final conclusion there. Okay? So that's the kicker, right? You do the graph, you write a little observation. Do the tables, write observations. And then you basically say, well, because of that graph and tables, I know my limit is approximately 1.099. And that's it. Okay? So a lot of people had the right idea there. It's just that they didn't necessarily get close enough to 0 either with the table or with the graph or both. Right? You had to get super close so then you can approximate the limit fairly accurately. Okay. Now, number 2, most people got, because it's just looking at this graph. All right, so you're saying part A, what's the limit as x approaches -4 from the left? Well, here's -4, so I'm looking just to the left of -4. So what's happening just to the left of -4? You're getting closer and closer to 6. So this one is actually 6. And then B is saying what happens as you approach -4 from the right. So over here you're looking like this. And as you approach -4 from the right, you're getting closer to 4. Right? But remember what we said about left-hand and right-hand limit? If they're not equal, then the two-sided limit, right, just the limit as x approaches -4, doesn't exist, right? Because the a and b are not equal. So since a and b are not equal, c doesn't exist. Okay? And then they ask you for f of -4, which means what's the value of the function at -4? Well, just look for the closed circle, right? The closed circle is up here at 6, so f of -4 is 6. Okay? And then E says the limit as x approaches 2 from the left, so you're looking over here. What happens as you get close to 2 from the left side? You get close to 2. Y gets close to 2. And then what happens as x approaches 2 from the right side? You're looking over here. What happens? It's also getting close to... Oops, I erased that. Sorry. It's also getting close to 2. So in this case, the left-hand and right-hand limit are equal. So then the limit as x approaches 2 of the function is also equal to 2. Okay? And then, of course, f of 2 is this point. 2, 2. So f of 2 actually equals 2. Right? So really what you're getting at is, at 2, the function's continuous because the limit is equal to the value of the function. Whereas at -4, it's not continuous, right? Over here, there's what we called a jump discontinuity at -4, because the graph jumps from being up at 6 to being down at 4. Okay, so that one was pretty straightforward. Most people had that one correct. Okay, now 3 is just all algebra, really, right? You're finding this limit. Okay, so let's see if direct substitution works. You plug in 0, you would get 1 over -2 plus 1 over 2, which is really -1/2 plus 1/2, which is 0, over 0. Okay, so that's not going to work. So you got to do some kind of algebra. So what you're going to do is you're going to try to simplify this complex fraction. And how do you do that? You multiply the numerator and the denominator by the LCD. And the LCD in this case is just 2 times t minus 2. So what you're going to do is you're going to multiply the top by 2 times t minus 2 and the bottom by 2 times t minus 2. Alright? So you're going to have the limit as t approaches 0 of what happens when you distribute here. Here the t minus 2's cancel, so you've got 2. And over here the 2's cancel, so you have t minus 2. And then this is just over t times 2 times t minus 2. Alright, I'm not going to distribute that. And you can see now why I'm not distributing that, because you can see here how this, in the numerator, the 2 and the -2 are going to cancel. So then what happens? The numerator is just going to be equal to t. But then nicely, I also have a t in the denominator that will now cancel out with. So now I'm going to just have the limit as t approaches 0 of 1 over 2 times t minus 2. And now finally, at long last, I can do a direct substitution. And when I plug in 0, I get 1 over 2 times -2, which is -1/4. So that's actually my limit there. And if you do that on converge, you'll see that the limit is actually -1/4 also. Right? but that would be on a non-calculator problem, right? So you would have to have done that by using the algebra. I mean, I even said that in the question. I said use algebraic techniques. So, I mean, all you could have really done on the quiz was check it pretty much. Okay, so those are the first three, and then there's just one more.